Hey, what's up, y'all? This is Lucas Allen, and for my final project, I chose to compare female height to their shoe size. This data will help us understand if there's a relationship between the two, and I'll take you through the various steps I've followed to analyze this data, including summary sheet, confidence interval for the mean, hypothesis test for proportion, and examining correlation. Let's start with the summary sheet where I've organized and analyzed the data. Here I've standardized the data and ordered it from lowest to highest to make it easier to interpret. The minimum height in the data set is 53 inches and the maximum height is 69 with a range of values in between. So the lower fence I calculated to be 56.24 and the upper fence to be 69.38. Looking at the raw data and comparing it to the fences, we can confirm that no outliers exist as all values fall within this range. So for the histogram of the data shows a right skew distribution with higher values pulling the mean towards the right. This right skew tells us that the median will be greater than the mean because the larger values have a stronger or less of an influence, a stronger influence on the median. Sorry. I also calculated the mean height, which is 63.57 inches, and the median, which is 64.45 inches. And then, moving on to the confidence interval, I was tasked with estimating the average female shoe size in the population with a 99% confidence. Using the data from my sample, the 99% confidence interval for the mean shoe size is between 6.91 and 8.41. This means that I'm 99% confident that the true average shoe size for all women falls within this range. In this section, I also calculated the alpha value, which is 0.01 for a 99% confidence level. Alpha represents the probability of rejecting a true null hypothesis. So here, 1% of error is acceptable when estimating the population mean. Additionally, the standard deviation of shoe sizes is about 1.524. Sorry. Showing that shoe sizes are spread out around the mean by about 1.5 units on average. And then let's go on to the hypothesis test. So the question I was testing is, do more than 50% of female shoe sizes in the US exceed size 8? And here, the null hypothesis is the proportion of women with shoe sizes above 8 is 50%. P equals 0.5. The alternative hypothesis is the proportion of women with shoe sizes above 8 is greater than 50%. P is greater than 0.5. I set the significance level to 0.05, which was the standard one given. And after conducting the test, I found that the p-value was 0.02442, which is less than 0.05, so we reject the null hypothesis. This means that there is enough evidence to support the claim that more than 50% of women wear the shoe sizes above 8. All right. Also, in the data set, there were 13 shoe sizes above 8 out of 31 total values, which corresponds to a sample proportion of approximately 0.42. This p-hat being lower than 0.5 supported the rejection of the null hypothesis. Now, moving on to the correlation analysis. this is where things got a little bit tricky for me, to be completely honest, and I might have made some mistakes. But so here, the first question is whether a linear relationship exists between a woman's height and her shoe size. I found the correlation coefficient to be 0.74817, which indicates a moderate to strong positive correlation. This means that generally, as a woman's height increases, her shoe size also tends to increase. So this, moving on to the slope of the regression line was calculated to be 0.24829, and the y-intercept at negative 7.82746. I was a little confused by that y-intercept, but I think it works out, and the line of best fit seems to work. Sorry about that. The p-value, and this is where I really am worried I might have made a mistake here. The p-value for the correlation was 0, 0, flat 0, as you can see, which, if that's correct, is extremely low and confirms that this correlation is statistically significant, not due to random chance. Based on the regression model for a woman who wears a size 10.5 shoe, I estimate her height to be 71.83 inches. And conversely, for a woman who is 75 inches tall, I must estimate her shoe size to be about 11.6, as we can see. So I would caution against trusting this estimate too much. And like I said, I very well could have made a mistake somewhere here. But I would caution against trusting this estimate too much because it involves extrapolation, which is estimating beyond the range of the data. So I would probably say that the shoe size of 11.6 for a woman who's 75 inches tall seems a bit extreme and probably unrealistic. I'm not sure. I don't want to say for sure, and I could be wrong again. So I would trust the height estimate for the 10.5 shoe more because it falls within the observed range of the data. So that is my final project. I apologize. Please let me know if I made mistakes. Thank you so much for listening. I really appreciate your time.